Hey, welcome to the Virtually Speaking podcast. My name is Pete Fletcher, and joining me as usual is my good friend, Mr. John Nicholson. John, how you doing, man?
I'm looking at the new Toyota 4Runner. I'm really confused.
Okay.
Historically, you just got like a V6 or V8. It was really simple. But the performance is so much more complicated now. They're going to this, it looks like an i4, but there's a turbo. And then there's also like a mild hybrid boost, like through the transaxle. Like there's a lot of nuance to the performance now when trying to look at cars. It's no longer like big engine, go fast. Like it's, you've got all these different components and how they come together and how that performance works. It's got a lot of kind of subtlety and nuance, and it's fun and it's complicated, but yeah.
I don't want to sell you out, but don't you drive a Tesla? I mean, that was a great segue. Don't get me wrong, but
Well, it's kind of like all flash is better than hybrid. I do enjoy a good, all EV platform, but
yeah.
it's good to understand what's going on under the hood of storage. So
Yeah, absolutely. You definitely need to understand what's going on under the proverbial hood. Absolutely. And so joining us today to talk about performance testing and HCIBench specifically is a good friend of ours, Mr. Chen Wei. Chen, welcome to Virtually Speaking.
Hey, Pete. Thanks for having me. Hey, John. How's it going?
Good.
Chen, give me the quick description. Like, what do they pay you to do here at VMware by Broadcom?
Well, I joined VMware back to, let's say, 2011, basically 13 years ago as an intern. My first project is kind of doing searching work for the database as a service. After I graduated, I just officially joined VMware in 2012. Then, been through different projects, including, database as a service, VBlob, vSAN. Then, I come up with this HCIBench work, as well as right now I'm kind of managing a team. We have a bunch of SME dealing with the workload, running on top of the VCF.
Nice, running workloads on VCF. So is that from a performance perspective, or is that part of what
everything?
Your job is?
We cover everything, including performance, best practices, as well as those kind of lifecycle management, how we should design, architectural layout. So basically, we cover everything for customer to help our customer to understand, hey, what's the best practices, what we should follow, what's the guidance by running certain application on top of VCF or we're being the product.
Yeah, well, performance is a big conversation, right, John?
Yeah, and I think Chen's underselling it. There's, this group, it's pretty incredible. There's a lot of work that, you'll see publicly. You'll see, Deji or Sudhir or somebody on stage talking about these things, but there's also quiet work done behind the scenes with these application vendors. So that way, when new versions of their software come out, when new versions of our software come out, joint support statements get issued, as well as in some cases entire features are done just for a single application vendor to make them more comfortable or enhance the platform in that direction. So it's a lot of nifty kind of under the hood work.
Yeah. And one of the things that came out of that work, many things, of course, but certainly one of them is something that folks listening to this podcast are probably familiar with, and that's HCIBench. And we're going to talk a little bit about what HCIBench is, and how people use it, and maybe what's going on with the latest version. But before we do that, Chen, why don't we set the foundation? Like, what is the background of HCI or Bench? Like, how did it start? And tell me a little bit more about the beginnings of it.
Yeah, I mean, the beginning is pretty interesting. When the early stage of vSAN is about like 2014 or 15, I was kind of new to the storage world. And my manager asked me to, hey, probably you're going to run some competitive testing, from vSAN perspective against other storage vendors. So see how each of the, the storage platform works, right? Then I was thinking of the way to automate the testing. Initially we just spinning up a bunch of VMs running the video bench testing inside of it and aggregate the results and then compare results. That's kind of starting from simple. And after its project down, vSAN won the game. And, my manager asked me, hey, why not just, publish this tool for field, for customer, when they come up to vSAN or any vSphere storage. They're going to have an easy way end-to-end solution automation in order to get the performance testing down within few hours without put their hands dirty. They just need to kick a few buttons and get the numbers, show to the executive. That's it. So, I mean, it's pretty interesting how HCIBench being introduced. it was designed for vSAN, but it not only cover vSAN, right? It can cover all the kind of data storage or storage based on vSphere, VCF. That's
So I
included.
can use it with my fiber channel array, my NVMe over
Yes, you
Fabric
can.
array. You know,
Even
it's
local VMFS.
I remember even local VMOS. I remember the dark ages before HCI benched, where if people were doing performance testing, you had to go manually deploy OSs, deploy these tools, try to make sure they were done consistently. Then try to figure out when the benchmarks on one of the nodes came back different, try to figure out what was going on. You're often using kind of very dumb synthetic generators, stuff like
Oh yeah.
iometer or crystal disk. And I still see people occasionally, they'll like benchmark one VM and one disk and be like, I don't like the results of this. And, you
Yeah.
know, explain like what do you see in aggregate that's different of running these multiple VMs, multiple disks versus just that single workload generator?
Because HCI was introduced around like 2013, 14, that time frame, right? And people
Yep.
did not quite understand about the architecture, how HCI works. But think about it: you have a vSphere cluster, you have anything. You would not just spin up one VM with single VMDK in your cluster and you start to judge this cluster sucks and the performance sucks because you're not seeing the performance you want. However, you're going to think about everything as a whole. Hey, as a cluster, what's the performance look like, right? What's the potential maximum IOPS or throughput I was able to achieve using this cluster? Or what could be the minimum latency I was able to achieve? What the scale looks like? What's the efficiency looks like from a cluster? So if you only think about from a single VM with single VMDK perspective, I mean, it's not old school, but I would say it's not realistic from the world.
Yeah, from
No,
a
that makes
lot of
sense.
consultants would use a lot of those synthetic workloads for, just to show like, oh, look how this works on this. But it never was true to real workloads, like IOPS, especially. Like you can't really measure on some of those tools. I think that was one of the big shortcomings on a lot of the benches. And so, how is the testing differentiated, like with the VMs that you create? How does that make it better than say like a synthetic workload?
One interesting I'd like to share is so there's some famous competitor of vSAN. They always post something pretty fancy. We achieve 1 million, 200 billion apps within single VM. I mean, because we're doing the performance testing, we know that's pretty easy if you can do some sort of cheating. For example, if you do the read performance, and if you have not written down anything to the storage layer, everything basically is from the memory, right? Then you can see extremely low latency while you have 1 million or 2 million IOPS out of the performance of the cluster. And you show customer, hey, this is how the performance looks like on our cluster. But as we know, it's not true, right? It's basically just we call it fake read because you don't have anything in your storage.
Yeah, the 512 byte read test that has a 10 megabyte working set. It's I'm going to test the acceleration for 10 milliseconds of my car. Wow, that was
Yeah.
really fast. Let's pay no attention to anything else. It's
Exactly.
interesting because in storage, I feel like there's what we call these cheesy benchmarks or these been various derogatory terms called them over the years, but it is interesting of trying to have a level set way to test at scale and do so and get a more indicative of what's going on. So let's dig a little bit into the tool. I know historically it was hosted on the Flings website. Where is the new home for HCI Bench and what all is going on there?
Absolutely. So let me just share my screen quick. All right, here we go. So originally we published HCIBench on Flame side of VMware, right? And everybody knows due to the acquisition, and we do have some changes to the Flame side. That's why HCIBench kind of, moved from the Flame side to GitHub. That happened last year. The reason we moved to GitHub is not only want to still publish HCIBench to our customer, our partner, and our few but also we are trying to engage more people to contribute the code, the
Ah,
idea, and discussion within this platform. And if you're looking at that, we have people, post couple of issues, and we have people engaging in the discussion, talking about, hey, what kind of feature you guys can look into in the future, right? So, for example, if you look at this one really quickly, and somebody actually talking to me saying, hey, you know what, we're not testing vSAN, but we're using HCIBench, right? So think about to have the NVMe adapter being enabled for HCIBench. In that case, we can know what's going to be the performance looks like by configuring NVMe adapter within the VM instead of pVSCSI controller. Then actually I did some change. I told them, oh, okay, for right now the code is ready, but you just need to change some code. How you can do that? Just to show them some basic procedure that they can achieve right now. So that's pretty interesting. I have more, I would say, active discussion within this GitHub, site, and rather than just a very passive way, just receive people requests and basically I prefer the GitHub more than Flame.
Yeah.
Well, yeah, I remember it was just like a wrong running comment section, and people can also make suggestions or pull requests. And it looks like also this is under the MIT license now.
Yes, I believe so.
Open source, yay.
Open source. Yeah, I think it's great that link below for folks that want to take a look at that. But I think it's great when you have open source like that and you can share and then get feedback. I think the other great thing about it is like, yeah, how often is it that you can use a tool and be like, hey, I really wish it did this. And then the developer jumps on and says, okay, here's some code to fix that right away. Like that's
exactly.
That's a
So,
beautiful thing.
we're kind of aggregating the code for a certain stage, then we publish a new version, right? If you're looking here, we actually have the 2.2A1 and 2A2 published already, and I'm about to publish 2A3 based on the changes I've made in the past few months, and also based on the recommendations or bug or features raised by different group of people.
I was just going to ask, so what are some kind of, if someone's deploying this, what are some of the features that you recommend they look at, or what are some of the just quick tips that you think sometimes people may miss with HCIBench?
So here, let me show a quick instance of HCIBench, right? I basically deploy the HCIBench. If you were the first time using HCIBench, right, you don't know what this tool can do for you. And if you're testing against vSAN, there is an easy run button that you can click. And you don't have to specify those kind of detailed information, like how many VMs you want to deploy, CPU, memory, disk information. You don't need to specify any of those. It's going to decide for you automatically. So how does it work? Basically, if you choose to use Easy Run, HCIBench basically can automatically detect your vSAN environment and deploy a number of VMs, let's say 4 VM per host, with 80 VMDK per VM, and give you a proper configuration of the thread count. So you just need to select one or more, those workload you want to testing using Easy Run. Then you just click Start button and save the config, and click Start button. Then you can just wait for the results in a couple of hours. That's it. So I mean, for a first-time user, I highly recommend use Easy Run for testing your vSAN. Also, if you come up with a new vSAN cluster, right? Let's say you have a new vSAN ESA setup or vSAN Max setup in your environment, you can also use Easy Run because you probably want trying to find out, hey, what could be the maximum IOPS throughput or minimum latency can be delivered from this cluster. Easy Run can also be a great option for you to, as a first time to HCIBench or first time to the vSAN cluster to use.
I like that, you run this before you put workload on it, so you understand the limitations of that cluster. And then if you're trying to troubleshoot performance, a year from now, you can say, okay, am I exceeding what this cluster was designed for? Or am I having performance problems and I'm at 1/10 what the HCIBench run was? Maybe there's something wrong with the network, or maybe something's going on. Help give you some indications, along with all the other tooling. I did see there's a vSAN debug flag. What is that for?
Oh, that's interesting. So if you have vSAN, right, if you're testing against vSAN, you can enable this. If you enable this, you're gonna need to fill out, the host credential information here. This looks silly, but I'll get rid of this. So basically, you can do host 1 and root with whatever password. Then you fill out host 2 if they have different credential, and you have root, and you have whatever other customer the password, right? So if all the hosts have same credential, you just need to fill out the one line, and it's automatically applied to all the hosts. And I'll show you what vSAN debug mode will get you. right? So in short, vSAN debug mode will grab more information. First of all, it's going to grab the VMK stats during the testing. It's going to tell you what's your different world, the CPU utilization looks like. In the end, it's going to jump into a flame graph. So if you have vSAN debug mode enabled, within this testing results folder, you should be able to see this little folder called vSAN debug. You click on it. We have 4 hosts. And for each of the hosts, we have the VMK stats collected and parsed. So if you go deeper, you can see those flame graphs of each world. Well, this is more for, I would say, vSAN or performance engineer within VMware to look at. The procedure basically is like, once you think there might be something going wrong with my vSAN system, you may want to retest using HCIBench by turning on the vSAN debug mode. Then those information will be collected automatically, and you can basically ship those information to vSAN engineering or GSS. Then we can significantly shorten the time at GSS asks you, hey, could you reproduce this for me, and could you collect those information for me? So they're gonna have those information already. This is for VMK stats. But more importantly, John, we have something called humbug within VMware, right? So basically, we ask customer to collect support bundle, either for past 2 days or past 2 hours after run testing. We collect support bundle for 2, 5, 10 gigabytes, right? When ship it over to FTP side for GSS to look at. The beauty of new HCIBench to vSAN debug mode is when you turn it on, it's going to collect the support bundle automatically of each test case.
Mm-hmm.
So for example, this is test case just ran, this is about AK 50% read. Once you turn vSAN debug mode on, the support bundle automatically collected. But look at the size. It's just 4 megabyte comparing to 5 gigabyte. Reason being is I tuned the script a little bit. That allowed the bundle collection only collect the time range during the testing happening. You know what I'm saying? So
So
it's
you're not
not
just dumping the entire
exactly.
performance database.
Exactly.
Yeah.
So you just need to focus on this particular time range, and you can figure out what's going on. Then you can just ship this bundle to GSS. GSS can figure out what's going on there. Plus, if you want to do something by yourself, of course, we allow that. And you go look at the results. Right? We also parse the support bundle locally within HCIBench itself. So when you're looking at the results, and it's going to tell you for vSAN performance stats graph, you can just copy paste this and go here. Then you will see exact same graph as GSS and vSAN engineering or performance team.
Oh, fancy! And that looks like a Grafana dashboard. This
is Grafana. This is Grafana dashboard, but this is built in within HCIBench. So for each run, you should get a link for that exactly. And if you're looking at the time range, just for 1.5 hour, which is testing happening.
Yeah, and I love how Grafana, you can like highlight a section, it'll zoom in, like it's a fun platform. So
oh yeah, for sure.
Yep.
So I know, vSAN obviously has the original storage architecture, also has the express storage architecture, and that architecture is very different, especially as it pertains to performance and the way we handle our caching and all that. Were there any changes to HCIBench, or does it handle the differences between vSAN differently?
I would not say change, but some enhancement, right? I would say vSAN ESA comparing to vSAN OSA is kind of enhancement. From the easy run perspective, yes. So it's going to deal with OSA and ESA differently because OSA is based on disk group. So the basic algorithm we're using for OSA is like, hey, we're going to put 2 VMs per disk group, and we basically calculate the thread count or the queue depths based on the number of disk group. But once we move to ESA, we don't have to worry about disk group. We just look at each host. So for example, how many VM we're going to target on each host, and how many thread count we can target for each host. This is one change, right? We get rid of disk group calculation. Another thing is, for easy run specifically, it's gonna tell you how you should prepare your VMDK before running testing. Think about prepare VMDK just like when you're testing a database, you're gonna pre-feed the data into a database in order to know what's the real performance of the database, right? So for example, what's the performance of insert, update, or delete, something like that. So prepare data is doing the same thing. Because for ESA right now, we have the compression enabled by default. And basically, HCIBench is going to find out from storage policy perspective whether compression is enabled or not, right? If compression enabled by default, okay, so basically it's going to use random as a method to prepare the VMDK. If you're using, all writing down all zero, it might be just compressed. You cannot basically prepare all the physical layer of the storage. So there are multiple couple differentiation between differences between OSA and ESA in that matter. And also for ESA, when we're doing easy run, we tend to design more thread count per host because ESA tends to have way better scale than OSA. That's from our experience. So there's some differences, but of
So
course there's some
it feeds
similarity.
more CPU threads to the worker VMs.
Exactly. Yes.
Oh, fun.
So it seems like to me that if you have a vSphere environment, you're definitely going to want to use HCIBench. Why is this not productized and inside of like VCF or SDDC Manager or something?
That's actually engineering and product manager asked me a couple of times. We want to stay unbiased, right? Because we do have some customer come in and ask, hey, I don't want to use the HCIBench because it's produced by VMware, right? It's it's come from vCent team. It's hard for us to say, hey, you know what? This is actually we're actually using FIO or VDBench as IO engine. HCIBench just end-to-end automation wrapper. They don't really care. They think, oh, this is a product. You just showcase your own performance, right? So we still want to stay a little bit, I would say, unbiased. So that's why we're kind of publish this as a solution instead of the product.
Yeah, if we productize it, then they've got Chen's got to carry a pager. So right now he can go on vacation and answer your GitHub pull requests, a week later. So hopefully you don't have benchmarking emergencies though. Like that would be weird. Yeah. So,
well, you bring up a really good point because I guess I hadn't really thought about the aspect of like bias for companies. So, for example, if someone was trying to evaluate software, you're not going to go to the person trying to sell you the software and say, hey, look at this tool we made to show you how we are better.
Don't ask us how it's made. Yeah, that's the nice thing about this being a wrapper for FIO and VDBench, which are industry standard. FIO is generally an upstream Linux. VDBench, I think Oracle releases that, right?
Yes.
Those are bog standard, and you can look at the wrapper code and see there's no real funny business or anything. So.
Yeah, exactly. Yeah. Another reason we open source this is just trying to have the user trust us. Hey, we're not hiding anything, right? We're not hiding anything from you. Everything is transparent. You can dig the code by yourself, and you can even contribute the code yourself. So we're not hiding anything, and we're letting the customer know the performance we're building or the number we're showing from HCIBench is all real from your cluster, whatever it is.
Yeah, this essentially just creates some automation in the steps that you're going to want to do. And but still uses the technology for the tools under it to actually the engines of those tools to actually do the work. That makes perfect sense.
Yep. The only flavor to vSAN, particularly just we simplify the process of debugging vSAN itself. That's it. So we're not actually just preferring any kind of storage in sense of on top of vSphere or VCF. vSAN just part of the customer.
So in regards to application testing, I know you and your team have validated a ton of different applications. What has been in pipeline lately? What have you been working on? What have you had some kind of interesting surprises with? Anything you want to share across the application validation side?
Absolutely. So, for the past few years, my team published over 70 or 80 reference architectures around different applications and different VMware product, right? Including vSphere Cell, including vSAN, and VMC, and on different platform. We were targeting most likely it's about the best practices, architecture design, and what's the performance look like, right, as a reference architecture. For this year, we're not going to explore new workload except there's a customer ask, right? We're not basically explore new workload by ourselves, but instead we're going to enrich those workload we've developed already. So for example, let's talk about Cassandra or Cockroach DB or Kafka, right? So previously, if you're looking at a reference architecture right now, it's just show you, hey, what's the best practices, what's the architectural design, what's the performance look like. So right now, we're trying to introduce more dimension into each workload. From a monitoring perspective, hey, how you can use, let's say, ARIA Ops to monitor your application, right? How you can leverage ARIA Auto to do the lifecycle management of your application. And more importantly, how can you do the protection from IT perspective of your application, as well as how can you do migration of your application, right? So basically, we can talk about how can you migrate from your brownfield existing bare metal or hyperscaler to VCF environment, or how can you migrate within different VCF environment, and how can you leverage the most recent VMware technology in the live recovery to protect your applications, and how can you use the ARIA ops to monitor your application, from a single places. That's something we're trying to achieve this year, and stay tuned, and we can have more exciting things to come.
Nice. Where do people go to see the reference architectures? Where are those
So,
parked?
so right now they're still staying on TechZone. If you go to core.vMware.com and you search the application you want to see, it's most likely going to be there. So for now, people pretty interested in SQL Server, Oracle, and those traditional applications, as well as VDI, SAP HANA, and we also publish a bunch of modern application or data services stuff like Kafka, Mongo, Cockroach, and my team also participates on AI work, right? So for example, we published the private AI reference architecture last year, and we're gonna have more to come this year.
Nice.
Yeah, go and check those out. I think Pete's got the link here, and I want to stress those are it's some really hardened technologists who are producing those. Those are not like marketing, using Chat GBT to say just pleasant things about how these
Yeah.
products coexist. Like they really get into the weeds. So check them out.
Yeah.
I
We're
like
also
it.
trying to feed our docs into ChatGPT, see what kind of model we can build out of it. That's kind of
Really?
interesting. Well,
I
it's something we're looking at right now, right? Because if you think about the future of monitoring. So monitoring is just first step, in my opinion, right? So first of all, your IT team should have the visibility of the application, identify what VM running what application, what's the application metrics looks like, and hopefully we can send the data over to VMware Cloud or premises via ops. Then we come up with something, the reference architecture stored in the vector DB and give you some recommendation. Hey, I see your SQL server is
Oh wow!
running
So combine the
low
document, combine
CPU,
the
exactly,
performance
and
data.
give you some,
Yeah.
yeah, exactly, give you some,
Private.
recommendation how you should tune your SQL server or platform automatically, or you can do that manually. So this is something we're still looking at, but I guess it's a fun thing to do.
Wow. Okay, Chen GPT. Stay tuned.
Chat
Um,
GPT.
I'm just it's always interesting because I've asked ChatGPT to muse on some things that are areas of my focus, storage economics and vSAN, and sometimes it comes back and I'm like, this is written in my tone, and I'm actually not happy about it. But then I realize, oh yeah, I'm the training data, and I'm pretty sure if you're asking about VMware optimization of Cockroach DB, like you're just naturally going to end up as the training data for public models. But I didn't think about taking that a step further and combining it all the way through. So. We just got to watch the tone on these things. So yeah, no Rauber GPT. This will be fun. So
Yeah.
I like it a lot. Well, cool, Chen. This has been super informative. We're going to leave some links in the show notes of the podcast to the reference architectures, to the GitHub.
Awesome.
But yeah, if you are a VMware customer, if you're using HCI, regardless of whether it's vSAN or not, you guys definitely should be trying HCIBench. Chen, thanks for all the information, and hopefully we can get you back on again soon.
Thank you, folks. Have a good one.
All right, take care.